Students, how are you feeling today? Hope you are good. Good. Yes, last time we discussed, in our last class, we discussed about energy as the ability to do work. Energy as the ability to do work. And we mentioned some forms of energy. I couldn't know. Can any of you remind us any form of energy you remember? Yes, can you remember?
No questions.
Okay.
No questions.
Okay, so now today we have another topic in continuation of that mechanical energy, work and power. So today we are going to look at mechanical work and power. Then, so work. For instance now, if I call you or look at me now, if I apply force to this and move it, I have done some work. If I apply force to this, I will continue doing this and I couldn't move it an inch, I've done no work, no matter the amount of force I apply. So for that reason, we define our LO here is to define work and power. Then again, to calculate work and power. Then by definition, work is said to be done whenever force is applied and distance is moved in the direction of the force. Remember, the emphasis here is that the distance must be moved in the direction of that force, because that could be an opposing force, and that is friction. Yes, so when friction is there and opposing force applied, if I apply force to this and I couldn't move it, there's opposing force, I have not done any work. Unless if my force applied overcomes the opposing force. Then the net force is what we give the body work done. Okay, so that is it. So by we said that work analytically, mathematically by formula, is product of force and distance moved. That is force times distance or displacement moved in the direction of the force. Which unit? The unit is joules, denoted by capital letter J. Do not forget that 1,000 joules will give you 1 kilojoule. In fact, any quantity in kilo stands for, in thousand stands for kilos. Some 1,000 meters gives you 1 kilometer. 1,000 grams gives you 1 kilogram. So that's the keyword. Kilo stands for quantity in thousands. Okay, let's proceed. So that, then when we come to power, some students have misconception between work and power. When you come to power, power has to do with the time rate of doing the work. The time rate of doing the work or utilizing energy. For instance, if I could move this, if I've done some work, maybe it takes me 5 seconds or 3 seconds or 2 seconds. Then the work I have done now, divided by the time taken for doing that work, gives me the power. That is to say that power, mechanical power, is equal to work done over time taken to do the work, or energy used over time taken. By the unit, we have the unit to be watts, denoted by letter W. And do not forget again that 1,000 watts gives you 1 kilowatt, and 1 million watts gives you 1 megawatt. The term mega stands for million. That's why in your data memory say 1 megabyte, 20 megabytes. That is thousands of millions of bytes. Okay, then with this now we can simply calculate this. Because we said we are now to define to calculate this. So from the definition of this, we say that power is the time rate of doing work, or the time rate of energy utilized. Then by example calculation now, quickly, assuming that a boy applies a force of, this boy applies a force of maybe 20 Newton to push an object, to put this object through a distance of, let's say, 5 meters. Then, and it takes the boy, the time taken was 25 seconds. Then we are asked to calculate, let's get